Hi, my name is Dr. Michelle Ploughman. I'm a faculty member in the Faculty of Medicine at Memorial University, and my research laboratory is located at the Leonard A. Miller Center, which is a rehabilitation center in St. John's, Newfoundland. And it's the center where one will come if they had an injury to their brain, such as stroke or traumatic brain injury, or an injury to their spinal cord, or MS, or Parkinson's. So we specialize in research in people who have neurological problems. So today we're going to talk about some of our research, talk about how exercise is brain food. So before we start, there's four key concepts that I want to tell you about regarding neuroplasticity. The first is, what is it? It's the ability of the brain to modify its connections or rewire itself. And that happens when synapses, which are the junctions between neurons, they become stronger or weaker in response to learning. For example, if you were to try to learn how to play the violin, you would need thousands of hours. And over those hours, your synapses would become stronger and stronger. That's neuroplasticity. And sometimes we call that task-specific training. So the thing that you want to learn, the task, you have to train that specifically. We also know that an injury to the brain stimulates neuroplasticity. So if there's a lesion in the brain due to inflammation or a stroke, there's an increase in the proteins in the brain that help make those connections in the synapses. And sometimes there's a discrete amount of time that'll happen, what's called the window of neuroplasticity. And finally, the excitability of brain connections influences their capacity for neuroplasticity. So there's just the right amount of excitation and inhibition. So you don't want to have too much excitable neurons in the brain, but you don't want to have inhibition either, because if neurons are not ready to fire, it's more difficult for the brain to learn. So I'm going to tell you about the ways we study neuroplasticity in two specific diseases. One is multiple sclerosis, which affects mainly young people, and the other is stroke, which most often affects older people. In MS, there's gradual loss of neurons in the brain, whereas in stroke, the blood supply to the brain is disrupted and there's a sudden loss of neurons in the brain. Both of them have lesions that disrupt this brain wiring and synapses, but the brain does undergo neuroplasticity especially after a new injury. So I'm going to tell you about two studies that test two ways to promote neuroplasticity and brain recovery. The first study was in people with stroke, and we knew that aerobic exercise increases proteins that support neuroplasticity. So we wanted to ask, can priming the brain with aerobic exercise help recover thinking and memory in people with stroke? The second study involved persons with multiple sclerosis. And knowing that task-specific training is important and it helps to relearn lost abilities through neuroplasticity, we developed an intensive walking training to enhance connections in the brain and spinal cord in people with MS with severe walking problems. So I'll tell you about the first study. We recruited 60 people who were more than 6 months post-stroke, who were very stable, but told us that they had problems with their thinking and memory as a result of their stroke. So we randomly assigned them to one of four groups, which I'll tell you about. But all groups received 30 minutes of physical training. One was an aerobic, fairly intense program, and was a lower intense activity program. And they also received 30 minutes then of cognitive activity. One was a brain training program that was developed by scientists at Dalhousie University, and the other was just computer games. And they participated in this program 3 days per week for 10 weeks. And here's what the groups look like. So the top two groups were the aerobic training on a treadmill, and we used a special harness so that people wouldn't fall. Then they got off the treadmill and they went straight to the computer, and they received either the brain training, the specialized brain training, or games. And then our activity groups received balance, walking, coordination training. It was lower intensity, but then they also received either the brain training or the computer games. That's 4 groups. And what we found was that when we paired the group that was paired the highly intense aerobic exercise plus that brain training program, we improved intelligence by nearly 50%. So on this graph, I want you to draw your attention to the red line and the red dot. That was the group that received the aerobic and the specialized brain training together. And here's another way to look at that. So that's the red group, and they were significantly better over the group that received the activities and just the games on the computer. We also found that the aerobic training groups made significant and sustained improvements in their fitness, meaning that when we measured them 3 months later after receiving their specialized therapy, they were still improving. So, and we also found that the aerobic training groups made significant and sustained improvements in walking. So what did we learn from this study? We learned that, yes, indeed, aerobic exercise boosts neurological recovery, that aerobic exercise may serve to prime the brain and work with other training to strengthen its benefits. So you can imagine if you wanted to learn something new, it might make sense to prime your brain with aerobic exercise first. And this aerobic exercise approach also improved fitness and walking. So there were multiple benefits, and there's hardly any treatment available that has as many benefits as aerobic exercise has. So the second study involved multiple sclerosis. And remember, I told you about task-specific training, so that you have to have this high volume of training to help relearn lost abilities through neuroplasticity. And we asked, can intensive walking training enhance connections in the brain and spinal cord in people with MS with severe walking problems? And we recruited people who were had MS for many, many years, and who used walking aids. And some people hadn't really walked outside for many years. We used the device TMS, or transcranial magnetic stimulation, to measure how easy it is to excite the brain circuits. So remember, I told you have to have this inhibition and excitation balance. So you want to have just the right amount of excitation so that brain circuits are ready to fire when you build training. But what we found is that in people with MS, that being fit is related to a more excitable brain. So on this graph, fitness is on the left-hand side, and the higher the value, the more fit you are. And on the bottom is inhibition. So when you move to the right, there's more inhibition. So you can see that people who have low fitness had a high degree of inhibition. And remember what I told you, if you have less excitable brain, more inhibition, it means that your brain is less flexible and less neuroplastic. So this is a concern. But what we found was that even in this preliminary study with 10 people with severe walking problems, this task-specific training delivered 3 times a week for 30 minutes each time for 10 weeks resulted in greater than 50% increase in the distance walked. And on this graph, you can see that on the bottom of the graph are the people who used walkers, power wheelchairs, and scooters. So they were having a lot of trouble walking, and they could walk with support of our harness 250 meters. But over the course of 10 weeks, they were able to walk a kilometer. And even the group, so we had the group on the top who used a cane, and they started off at about 1,500 meters, and they moved up to about 2,000 meters. So using this device, like I mentioned, TMS, we found that this intensive training increased brain excitation and reduced inhibition, making the brain more plastic. So I want you to look over on the left-hand side of this graph, and this is the inhibition in the brain. So we found when pre is before the intervention, post is at 10 weeks, and follow-up is 3 months later, where we haven't seen them for 3 months and we bring them back. And we found that brain inhibition did decrease, which is a good thing, after the 10 weeks of training, but returned to previous levels 3 months later. And similarly, on the right-hand side, you'll see it's called the active motor threshold, or AMT. And AMT is how much you have to turn up the machine to get a response out of our target muscle. And so in this case, the lower the AMT, the more excitable. And you can also see this same pattern, that excitability was increased after the training, so the lower AMT, but returned to previous levels 3 months later. So what did this tell us from this study? First of all, in persons with MS, and it's very likely this applies to you and I, lower fitness was related to inhibition of brain circuits. This inhibition is known to lessen your ability to learn new things. So that's why it's important to exercise. Following 10 weeks of treadmill training, this group of people with MS who used walking aids were able to walk further. So these are individuals that you would never think could walk a lot more, sometimes double or triple what they started. However, and then following 10 weeks of training, they showed greater brain excitability, activity, and less inhibition, which is a good thing. However, it did go back to previous levels, which suggests to us that if you don't maintain your exercise, the benefits to the brain seem to lessen over time. And this is the classic statement you've heard many times: use it or lose it. So exercise is brain food. We can use it to learn new things. We can pair aerobic exercise with a task that we want to learn. If we want to learn something intensively, we have to engage in task-specific training. But exercise seems to make your brain more excitable and more amenable to change. And that's a good thing, because we're all aging and our brains are all aging. And it can only be good. Exercise can only be good for your brain. Thank you very much.